All right, good morning, everybody. How are we doing? I've already gotten a lot of responses in the chat box, but just want to check in. How's everyone doing? Let me know, let me know. Looking good. Ryan, Christine, welcome to class. Kyrie, good to see you. Looking good. All right, let's go ahead and I'm going to go ahead and get us started up here. So this is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please do not share contact or social media info during classes for your own security reasons. All right, so today we are going to have a review day because tomorrow we will be going over the units 3 through 4 exam. Tomorrow we have the unit 3 through 4 exam. So today we're going to go ahead and start reviewing for that. Tomorrow we will go over as many of the questions as we can together. Anything that we miss, we'll go ahead and I'll send out a recording that goes over anything that we miss. But overall, you should have you should be able to do every single question. We'll go over the information. I won't give you straight up answers, but I will give you everything you need in order to be successful tomorrow on the exam. Go ahead and give me a music note in the chat box if you understand. Music note in the chat box if you understand. Again, the exam is tomorrow. Thank you, Anthony. Thank you, Christine. Welcome to class, Anthony. How are you doing? Looking good, looking good. All right, one moment. I'm doing well. Thank you. Hi, Sylvia. How are you? Jennifer, welcome to class. How are you doing? Just letting everybody know that remember the exam is tomorrow for units 3 through 4. We will go over the background information for each question together. So I won't give you straight up answers, but everything that we do go over should help you be really successful. So make sure you're in class tomorrow to go over that. Anything that we don't get to tomorrow, I'll make sure that I send out a recording that goes over the remaining questions because sometimes we don't go through every question. We don't have time in class. All right, so let's go ahead. We are going to do some review today. So grab your whiteboard tools and I want you to go ahead and begin to match up these terms. So you can see I have a cation, anion, and an ionic bond. And our definitions over here, a negatively charged ion that has more electrons, the attraction between a positive and a negatively charged ion, and then a positively charged ion with more protons. Just do your best, throw your guesses up there. Anything that you get incorrect, we're going to go ahead and correct today. So this is how we're going to review everything. So don't be worried, just try your best. If you make mistakes, it's not the end of the world. We will go ahead and fix them together. Excellent. I see Sylvia on the board. I see Ayla and Jalen working. I see Annette um, and Christine working. Kevin working on the board. Ryan up there. Amy, Natalie, awesome. Looking good, everybody. Let's go ahead and pause those tools. Looks like we're feeling pretty confident, so let's go over that together. Excellent, excellent. All right, grabbing my red tool here. Perfect. Yeah, so a cation, you are definitely correct. Cations are going to be positively charged. They have more protons because protons are positive. Remember that little T in cation looks like a plus sign, so think of that as positive. Anion, on the other hand, is a negatively charged ion with more electrons because electrons are the negative ones, so you need more of the negative subatomic particle. And so the N in anion reminds us of the word negative. And then don't forget the ionic bond is just those two different things, a cation and an anion, being attracted to each other because opposites attract. Excellent. Just want to remind people if you're coming in late that tomorrow we do have the units 3 through 4 exam. So today we're going to go ahead and start reviewing for that. Tomorrow we will go over each question that we can, whatever we have time for, and we'll go over the background info for each question. We probably won't have time to go through all of them, and I won't give you straight up answers, but we will go over the info. That way you're at least successful on those questions. So that will be happening tomorrow. The exam, again, is tomorrow. All right, let's go ahead and work on this top one together. So metals only have a few valence electrons. They tend to have 1 to 3 valence electrons. So tell me in the chat box, is it easier for them to lose or gain electrons? Is it easier for them to lose or gain electrons? Again, just do your best in the chat box. We're doing all of these checks because if we get anything wrong, we can review it. So that's the whole point. So it's okay to make mistakes. Yeah, exactly. They only have a few electrons, and so it's much easier for them to actually lose those electrons. And if you lose electrons, that means that you're losing negativity, right? Electrons are negative. So think about your own life. If you lose negativity, do you become more positive or more negative? Do you become positively charged or negatively charged? If you're losing negativity, losing negative electrons. Yeah, you actually become more positive, right? So if you lose negative electrons, you actually become overall positive. And again, this positive ion, is that an anion or a cation? That one we should know pretty easily. Excellent, Christine. Sylvia, looking good. Get some more answers in the chat box. Positive one. Again, think N for negative. T looks like a plus. Yeah, it's going to be a cation. That T reminds us of positive. Great job. Go ahead and do the second one on your own where it's talking about nonmetals. Nonmetals do have many valence electrons. They tend to have 5 to 7 valence electrons. So what is it easier to do? Remember, the goal is to either lose to get down to 0 or gain to get up to 8. Based on the octet rule, most atoms want 8 valence electrons. There we go. Amazing. Let's see who I've got up on the board. So much participation. Thank you, Sylvia, Christine. I see you, Amy, and Annette looking good. Ryan on the board. Make sure you're participating. If we don't see participation from you over several sides, we'll go ahead and check in with you in the check-in room. Excellent. I see Ayla up on the board. Let's get some participation from Anthony B, Anthony T. Thank you. I see Natalie up there. Let's get participation from Gabe and Jalen up on there. Kevin and Josiah, Jennifer, I want to see your answers up there too. Kyrie and Madison, go ahead, get your answers up there. Looking good. So yes, I would definitely agree that nonmetals, because they already have most of their valence electrons, they only need a few more to get to 8. And so yes, they are going to want to gain those electrons. If you're gaining electrons, that means that you're gaining negative electrons, which actually means you're gaining negativity. And you are correct, you become more negatively charged. And so finally, those negative ions are called anions. Excellent job. Hi, Ken. Welcome to class. This is a reminder that tomorrow you do have your Unit 3 through 4 exam. And so today we are reviewing some of that stuff, mostly from Unit 3 today. And tomorrow we will go over the background information for each question. I won't give you straight up answers, but that should help you be successful if you're in class tomorrow. Anything we don't get to tomorrow, because we might not have enough time in class, we will go ahead and I'll send out a recording that goes over the remaining questions. All right, let me know if you have any questions about that, Ken. Again, that exam is tomorrow. All right, so let's go ahead and review together really quickly. Lewis dot diagrams represent only the valence or outermost electrons on an atom. So the way that we do this is we take the dots, as the dots are the electrons, and we draw them in a square around the element symbol. We only do one dot per side, and then if we have more than 4 electrons, we will start to repeat it. The reason that we do one per side before we repeat is because electrons don't automatically pair up. Remember, electrons are all negative. They're all negative. And so inherently, if you have 2 things that are the same charge, in this case, 2 things that are negative, they don't want to be next to each other. They want to repel each other. So they'll kind of set themselves up as far away from each other as they can until finally they have to pair up. So take a look here. Oxygen is in group 16. Okay, it's in group 16. And remember, if you take a look at the ending number of group 16, how many valence electrons does oxygen have? Remember, the ending number of our groups tells us the number of valence electrons. That's how the periodic table is set up. Awesome. I see Sylvia. I see Annette working. Excellent. Christine working. Yeah, exactly. So oxygen is in group 16 and therefore has 6 valence electrons. In reality, it has more than just 6 electrons, but in this case, on its outermost ring, it only has 6. So let's go ahead and draw those. Again, I'm going to go ahead and start at the top. So here's electron number 1. Okay, I'm not going to immediately pair up. I'm going to go to the next side. Thank you, Kevin. Yep, 6. Next side, here's 2. At the bottom, here's 3. Over here, here's 4. And now I have to begin to repeat. Right, so now we have a pair at the top and a pair over here for a total of 6. Go ahead in the chat box, give me a birthday cake if you understand how I made this Lewis dot diagram. All right, birthday cake in the chat box if you understand how I made this Lewis dot diagram. All right, good. So let's go ahead and I'm going to give you polling tools. And again, if I don't get a response, I'll go ahead and move you to the check-in room. So make sure you're with us. Which of these is a correct Lewis dot diagram for phosphorus? Take a look at phosphorus, count up its number of valence electrons, outermost electrons. So again, ignore the inside. Okay, only look at the outermost shell. All right, count up the number of valence electrons and then figure out which of these correctly represents that. And don't forget, you do have to go to every side first before you repeat. So one of these did not go to every side. All right, so be careful, there is a trick one up there. Excellent, waiting on a response from Annette. Annette, thank you. Anthony T. Ayla, waiting on your response, thank you. I see. Awesome. Waiting on Jalen, Josiah, Ken, Madison, and Natalie. Go ahead and give me your responses. Again, count up the number of valence electrons on the outside of phosphorus, and then make sure that you go all around. Remember the Lewis diagram, you cannot pair up until every side has at least one electron. Looking good. Madison, Natalie, are you there? Make sure I get your answer. Thank you. Ken, waiting on your answer as well. Just waiting on Madison and Ken. Madison and Ken. Anne-Marie, welcome to class. We are reviewing for the exam tomorrow. Thank you, Ken. Awesome. Looking good. All right, let me go ahead and publish these up to the board. And let's clear these out. Looking good. All right, so it looks like we are pretty sure that it's either B or D, and I would totally correct. I would totally agree with that, right? A and C don't even have the right number of valence electrons. If we count up here, phosphorus definitely has 5 valence electrons. 1, 2, 3, 4, 5. All right, perfect. However, remember when we draw the Lewis dot diagram, remember we have to go all the way around first before we can repeat. So you can see here that one side of this phosphorus does not have an electron, and so we didn't go all the way around here. Go ahead in the chat box, give me a thumbs up if that makes sense. Thumbs up if that makes sense. So for this one, we did not go all the way around, and so B, while close, is actually going to be incorrect. B, while close, is going to be incorrect because they did not set up the electrons correctly. All right, so this one, D, is actually the most correct because you can see here they started out with this electron at the top. 1, 2, 3, 4, and then finally repeated right here. So I can also draw those out. So here's 1, here's 2, here's 3, here's 4, and finally they had to repeat and pair up, and there's number 5. Great job, everybody. Looks like we are on the right track there. Looking good. Let's go ahead and move on. All right, so let's go ahead and talk a little bit about how we can use Lewis dot diagrams to take a look at how things pair up. Okay, so taking a look here, sodium is in group 1, so how many valence electrons does sodium have? If sodium is in group 1, how many valence electrons does sodium have? Yeah, exactly. It only has one valence electron, so I'm going to go ahead and draw one right there. And then chlorine over here, Cl. Cl is in group 17. Take a look at the last number. How many valence electrons does chlorine have? Only looking at the last number of the group. Yes, exactly. It has 7. So here's 1, 2, 3, 4. Oh, sorry, I'm doing it wrong. I should do it right so that you can see how it is done, right? So here's 1, 2, 3, 4, and then I begin to repeat 5, 6, and 7. Good. All right, so taking a look here, sodium only has one valence electron. What does it want to do? Does it want to lose or gain more electrons? If it only has one, does it want to lose or gain? Yeah, exactly. It wants to lose, right? So this one wants to lose. And chlorine already has 7, so what does chlorine want to do? Lose or gain? What does chlorine want to do? Lose or gain? Yeah, chlorine wants to gain. And so they can actually work together. So what we can do here is sodium can actually give its one electron away and give it to chlorine right here. And so what we end up with is we end up with sodium that no longer has any electrons. And I'm going to go ahead and put it in a bracket to show that. So it no longer has any electrons. And chlorine, on the other hand, has 8 electrons. So let me go ahead and show what that looks like. Here's chlorine. Chlorine now has 8 electrons, right? So let's take a look here. So 1, 2, 3, 4, 5, 6, 7, 8. All right, so if sodium lost 1 electron, it lost 1 negative charge. Now overall, sodium should be positive, and specifically a positive what? If it lost 1 electron, it should be positive what? Not a trick question, tell me in the chat box. It should be positive what? Sodium loses 1 single electron, then its charge should now be positive what? Awesome, I see Annette. I need more answers in the chat box, please. 1 electron? Yeah, if you lose 1 electron, an electron is a -1 charge, so this one's a -1 charge, and if you lose that -1, you actually become positive, right? So sodium gets a +1 charge, and if chlorine gains a -1 charge from an electron, now chlorine has what charge? Tell me in the chat box, now what charge does chlorine have? If it gains that 1 electron, that 1 negative electron, awesome, I see Amy. But remember, it's gaining a negative, so it should be negative what? Chlorine is now what charge? I'm waiting on more participation in the chat box. If chlorine gains 1 electron, which has a -1 charge, then chlorine's charge is now what? If it gained 1 electron, 1 negative electron. It's not a trick question. If it's gaining -1, what should be its charge? Negative what? I need a number. It's losing 1 electron. Awesome. Thank you. I see Sylvia in the chat box. I see Annette typing. Awesome. I see Anthony. I see Ayla. I see Jalen. Yeah, exactly. -1, right? So this one becomes a -1 charge. Excellent. So now that we have a positive charge and a negative charge, a cation and an anion, now they are going to be attracted together, and this creates our ionic bond. This is the ionic bond. Go ahead in the chat box, give me a thumbs up if that makes sense. Thumbs up if that makes sense. If you lose 1 electron, you end up with a +1 charge. If you gain 1 electron, you end up with a -1 charge. If you lost 2, you'd be +2. If you gained 2, you'd be -2, and so on and so forth. Awesome. I see Annette with a thumbs up. I see Anthony typing. I see Ayla typing. Thumbs up if that makes sense. How we showed the ionic bond with the Lewis dot diagram. Perfect. Again, this is all review from Unit 3. That's why we're going over it together right now. So it might seem pretty unfamiliar, but we did go over it in Unit 3, and we want to review it right now. Great job, everybody. All right, so covalent bonds, on the other hand, we talked all about ionic bonds. Covalent bonds do not become positively and negatively charged. So covalent bonds actually just share their valence electrons, and this happens between nonmetals. So you can see the nonmetals are highlighted up here. We have hydrogen as a nonmetal, and then all of these on the right are nonmetals. Now, the reason that covalent bonds share electrons is because two nonmetals, neither atom is electronegative enough, it's not strong enough to completely take an electron. So they must actually share. As opposed to metals and nonmetals, one of them is stronger and so they can steal an electron. Here they have to share. Here they have to share. And most organic things, like in your body or in your food, are in fact covalent bonds. Let's go ahead and take a look at an example of this. So you can see how chlorine has 7 valence electrons, and this chlorine also has 7 valence electrons. Now, they literally have the same electronegativity or attractiveness to electrons. And so therefore, neither can steal. Neither can steal in this tug of war because they have equal strength. Okay, so instead they're just going to share their electrons. So you can see here chlorine has 7, this chlorine has 7, this chlorine has 7, but they each have 1 unpaired electron that they can share. So you can see right here, this chlorine will share its unpaired electron with this one, and this chlorine will share its unpaired electron with this one. And when we draw them, we can draw them as both holding on to the electrons together. So this time you'll notice that there are no charges. There's no ionic charges because it's not an ionic bond. It is a covalent bond. When you have a shared electron pair, you can actually draw that as just a single line. So you can see right here, chlorine is drawn as a single line between these two chlorines, showing that they're sharing a pair of electrons. Go ahead in the chat box, give me a star if that's beginning to make sense. So this line right here shows a pair of shared electrons. Right here represents a pair of shared electrons. Awesome. All right, let's go ahead and take a look at an example here. All right, so let's go ahead and do, let's go ahead and do hydrogen and oxygen, okay? So hydrogen and oxygen creates H2O, so that's water. And so I'm gonna go ahead and make this a little bit bigger. So here is going to be my H for hydrogen, here's another H for hydrogen, and here's an O for hydrogen. Okay, so taking a look at hydrogen, hydrogen is in group number 1. So how many valence electrons does hydrogen have? How many valence electrons do each of my hydrogens have if they are in group 1? Yeah, exactly, Sylvia, exactly, Christine and Annette. They have 1 valence electron each. Perfect. Oxygen, on the other hand, we actually went over this earlier. Oxygen is in group 16. And so take a look at that last number. How many valence electrons does oxygen have on its outermost shell? Valence electrons on its outermost shell. Thank you, Christine. Thank you, Sylvia, Annette. I see Kyrie typing. I see Ryan typing. Ayla. Awesome. Yeah, it's going to be 6. So I'm going to go ahead and draw them. So I start at the top. Here's 1. I go around, here's 2, 3, 4. I went around once, now I can repeat. Here's 5, and here's 6. So taking a look here, oxygen has 2 unpaired electrons, and each hydrogen has an unpaired electron. And so they can go ahead and actually share. So let me go ahead and get this closer and show you what this looks like. All right, so hydrogen's going to share its 1 electron with this oxygen, and oxygen will share one of its electrons with this hydrogen to create a shared pair. This oxygen will also share an electron with the other hydrogen, and the other hydrogen will share its unpaired electron with this oxygen. And so overall, we end up with what you can see here. So here's H, here's O, here's the other hydrogen. All right, so what they're going to do is they're both going to hold on to pairs. So these ones are going to share this pair, these ones will share this pair, and oxygen, don't forget, has 2 other sets of electrons. Okay, but remember that I can actually draw each pair as a single line. So let me go ahead and show you what this looks like. Sorry, give me a moment to move this around. Perfect. So instead of just drawing those shared electrons, I can actually draw it as a line. So here's O. All right, so I can draw this as a single line between these two, right here, a single line between these two, and then just leave the other sets of dots on oxygen. And that creates a water molecule. So they are shown sharing. So this right here shows that they share a pair of electrons. Let me make this smaller. Shares a pair of electrons. All right, go ahead and give me a green check if you understand that. Green check if you understand that. All right, I do need green checks from everybody, otherwise we'll move people to the check-in room. Green checks if you understand that. How hydrogen and oxygen decided to share a pair of electrons together, and we can show that shared pair as a single line. A single line shows a pair of shared electrons. Excellent. Green checks, please. Ryan, Madison. Green checks, Ken, Kevin, Ayla, Gabe, Gabby, Jalen. Green checks, Anne Marie. If you understand that. If you don't understand, give me a red X and we can review it together again. But green checks if you are good to move on. If I don't get a green check from you, I'll go ahead and move you to the check-in room. Waiting still on green checks from Kevin. And thank you, Jalen. Waiting on Gabe and Gabby. Gabe and Gabby, Kevin, Gabe and Gabby. Awesome. I do know Kevin participated recently. Looking good. All right, let's go ahead and move on here. Okay, so remember that we just talked about covalent bonds are sharing and ionic bonds are actually transferring the electrons. So here we go. Covalent bonds share, whereas ionic bonds actually transfer an electron or electrons over to a different atom. Now the thing is, there are 2 types of covalent bonds because we talked about how this is a tug of war. And in our example with chlorine and chlorine, they both have equal strength, and so they equally share the electrons. And so this results in what's called a non-polar covalent bond, meaning there are no different poles. There's not a difference between one side or the other side. Unlike the Earth has a North Pole and a South Pole, which are different. So nonpolar means the 2 sides are not different. Go ahead, give me a rainbow in the chat box if that makes sense. If it's the same 2 atoms have equal strength, and therefore it ends up being a non-polar covalent bond. Non-polar, they equally share. Awesome. Now, on the other hand, polar covalent bonds do have different poles. And what happens here is that even though nonmetals are still sharing, even though they're sharing, one of them is a little bit stronger. So here we go. We can see here, for example, that this atom is a little bit more electronegative. And so it holds on to the electrons slightly more. Again, it's not an ionic bond. It can't steal the electrons completely, but it can hold on to the electrons a little bit more. And so it becomes what is called partially negative. Not completely negative, only partially negative. This lowercase delta, Greek delta, means partially. So this is partially negative, and the other one becomes partially positive because it cannot hold on to those negative electrons as easily. All right, let's go ahead and take a look at some examples here. So in the bond between magnesium and oxygen, we can see that electrons are doing what? Are they being shared equally? Are they being transferred, or are they being unequally shared? Take a look at this Lewis dot diagram. What do you see happening to these electrons? Tell me in the chat box. Are the electrons being equally shared between magnesium and oxygen? Are they being transferred, or are they being unequally shared? What do you see happening? Awesome. I see Sylvia. I see Ayla working. I see Annette, Christine working. Let's make sure we're getting participation from everybody. Perfect. Yeah, they're actually being transferred. You can see magnesium is literally giving its electrons to oxygen. So these ones, excellent, are being transferred. And so what does this mean? Does this mean that there's a large difference, a small difference, or the same electronegativity between these two atoms? Actually, sorry, this should actually say zero. Large, small, or zero difference. All right, so is there a large, small, or zero difference between magnesium and oxygen? If one of them is strong enough to completely steal an electron, is there a large difference, small difference, or zero difference between the electronegativities? If one of them can actually steal it. Think about the strength in a tug of war. If oxygen is stealing the electrons, does it have a large difference, small difference, or zero difference in its strength or electronegativity compared to magnesium? Excellent. I see Sylvia. I see Anne-Marie working. Thank you, Annette. I see Ryan working. Perfect, Jennifer. Yes, yes, yes. Awesome. Yeah, it's going to have a large difference, right? So what this means is that oxygen is really electronegative. So oxygen is highly electronegative. It's good at stealing. Whereas magnesium has a very low electronegativity, and so it prefers to give away, Now, this creates what type of bond? An ionic bond, a nonpolar bond, a covalent bond, or a polar covalent bond? What type of bond do we end up getting? What type of bond do we end up getting? Excellent. I see Sylvia. Take a look here. We now have a positive charge here, a negative charge here. So what is that? What is that? Thank you, Annette. Yeah, anytime we have positive charges or negative charges, remember those are called ions. And so this is an ionic bond, as shown by its prefix, which says ion. We have positive and negative ions. All right, you're going to go ahead and try to do the next one on your own. So give me a lightning bolt if you feel comfortable with this so far. Lightning bolt if you feel comfortable with this so far. In this instance, we saw electrons transferred. We know that that means there's a big difference in their electronegativity. And we saw they create positive and negative charges, which are an ionic bond. Excellent. All right, let's go ahead and try this next one. I'm going to give you whiteboard tools. All right, we can see the bond between two oxygens. We want to know, are electrons being equally shared, transferred, or unequally shared? Therefore, what's their difference in electronegativity? Sorry, let me fix this one again. And does that make it ionic, nonpolar covalent, or polar covalent? Go ahead and circle up on the board. Awesome. I see Ayla, Sylvia, Christine, Amy working. I see Jennifer working, Ryan up on their board. Thank you. Want to see, let's see here, who am I missing so far? Would love to see Anne Marie up on the board and Anthony up on the board. Awesome. Thank you, Anne Marie. Want to see Jalen working. Thank you. I see Natalie up there. Kyrie, go ahead, get your answer up on the board. Looking good, everyone. Awesome. All right, let me go ahead and pause these tools. This looks amazing. Yes, in the bond between two oxygens, you are totally correct. They are equally sharing those electrons. We can see right here that those lines mean that they are sharing a pair of electrons. In this case, they're actually sharing two pairs. So they're actually sharing 4 electrons total. So sharing pairs of electrons, that's what those lines mean. Excellent. And that means that their difference between electronegativity is the same. They're the same atom, and so they have the same strength. Same atoms, same atoms, same strength. So no difference in electronegativity, and therefore they are non-polar covalent. Covalent meaning sharing, right? Covalent means they share. But non-polar means that the sides are the same. No difference between the sides. All right, awesome. So that one was right there. Let's go ahead and try the last one. Here you go. You have whiteboard tools. Between hydrogen and fluorine, are electrons being equally shared, transferred, or unequally shared? Is the difference large, small, or zero? And therefore, is it ionic, nonpolar, or polar covalent? Excellent. Sylvia, Jennifer got up there super fast. I see Annette, Christine working. I see Ayla on the board. Still want to see more participation from Kyrie, from Madison. Kyrie, Madison, get your answers up there. I see Anthony working up there. Anne Marie, get your answers up there as well. Ken, you too. Kevin, go ahead, get an answer up there. I see Natalie working. Awesome. I think that's everybody. Thank you, Kevin. Beautiful, looking good. All right, let me go ahead and pause the tools. Looks like we got most people up there. Looking good. All right. So yes, electrons between hydrogen and fluorine are being shared, right? You can see this line right here, which shows electrons being shared. But in this case, they're actually being unequally shared because you can see that hydrogen ends up partially positive and fluorine ends up partially negative. So this right here is unequal sharing. Unequal sharing. Okay, the difference between those electronegativities is therefore pretty small. So it's not large enough to transfer electrons, but it's not equal, right? So they're not the same, but they do have a little bit of a difference causing that unequal sharing. And when there's unequal sharing, you end up with poles. You end up with a slightly positive pole, a slightly negative pole, and therefore polar covalent. Go ahead and give yourself a gold star in the chat box. Great job on that, everybody. That looked amazing. Gold star in the chat box if that makes sense to you. Awesome, awesome, awesome. Cool. All right, let's go ahead and review together. I'll do the first one with us. Let's go ahead and review how to read chemical formulas. So remember that the subscript, the little number, comes after the number it refers to. So C goes with this 6. All right, so C6 go together and H6 to go together. So take a look here. How many carbons are in benzene? How many carbons are in benzene? Excellent. Yes, there are going to be 6 carbons in benzenes. I have 2 options here, this one or this one. All right, and so which one would make more sense? The one with 6 carbons, 6 hydrogens, or the ones with carbon, hydrogen, and oxygen, based on the chemical equation for benzene? Which one makes sense? The first one or the second one? First one or the second one that I underlined? Yeah, definitely for sure the first one, right? We see carbon has, there are 6 carbons and there are 6 hydrogens, but we don't even have an O in benzene. So there's literally no oxygen in benzene, so that would not make sense. Great. All right, go ahead and try the next ones on your own. Go ahead and try the next ones on your own. Remember that if there is no number, that just counts as 1. If there's no number after an atom, that counts as 1. No number after an atom. All right, awesome. These colors kind of remind me of like the Jamaican flag here. It's very pretty. All right, let me go ahead and pause these and let's go over the answers together, but it looks like we're pretty confident. I love it. All right, so methane, taking a look here, methane has no number after it, and so you are correct, it must have 1 carbon. It has a hydrogen with a 4 after it, and so it must have 4 hydrogens. Great job. Taking a look here, methyl alcohol has no number after it, again indicating only 1 carbon. There are actually 2 sets of hydrogens here. There's a hydrogen with a 3 and a hydrogen with no number, which counts as 1. So 3 and 1 actually makes 4 hydrogens, right? That's where we got that, 3 plus 1. And then lastly, oxygen right here had no number after it, which means 1 oxygen. Great job on that one. And last but not least, we have phenol, C6, so there are 6 carbons. H5 with an H without a number, which counts as 1. So 5 plus 1 gives us 6 hydrogens. And lastly, we saw same thing here. O has no number on it, and so that means 1 oxygen. Great job on this. Go ahead and give me a video game controller if you feel pretty confident with how to read a chemical formula. All right, video game controller if you feel pretty confident with how to read a chemical formula. Again, always look at the number after the letter, after the atom. Great. Thank you, Jennifer, Sylvia, Anthony, Annette, Natalie. I see you in the chat box. Great job. All right, let's keep on going. All right, so taking a look here, water is a polar covalent bond. All right, so keep in mind, we just actually set up water earlier, but water does have polar covalent bonds because of that unequal sharing between electrons. Imagine again that we have a really strong electron like the horse up here, that's going to be oxygen. right? So the horse up here, pretend that that is oxygen. Let me get a color that you can see up here. So this right here is going to be oxygen, whereas this little dog down here is going to be hydrogen. So if they are playing a tug of war between the electrons, oxygen is a little bit more electronegative, and so it attracts that electron pair slightly more. They're still sharing, it's just oxygen is a bit of a hog. It's a bit of an electron hog, much like if you share a blanket, oxygen would be the blanket hog, right? So oxygen is a blanket hog. All right, so oxygen is going to pull those electrons a little bit closer to it, making it partially negative. Remember that symbol right there, the lowercase delta stands for partial. Same thing with hydrogen. Hydrogen is going to not be able to hold on to those electrons as well, making it partially positive because the electrons don't spend as much time close to the hydrogen. Less negativity around the hydrogen. Now, the result is that water ends up having really unique properties. Water can dissolve substances extremely well because those oxygens can pull, those negative oxygens can pull apart solutes, and those positive sorry, oh my gosh, I'm losing my words. Those negative oxygens can pull at the positives in a solute, and the partially positive hydrogens can pull at the negatives in a solute. So we talked about already how water is the universal solvent, but again, this is the reason why. If you take a look here, all of those partially positive hydrogens can rip apart the negative chlorine and salt, and all of the partially negative oxygens can rip apart the positive sodiums from salt. And so water is really good at tearing things apart because of this unique property. Go ahead and give me a green check if you understand. Green check if you understand. Again, water is unique because of its polar covalent oxygen-hydrogen bonds. Polar covalent oxygen-hydrogen bonds give water really unique properties to tear things apart. Great. Yes, again, water is the universal solvent. Remember, solvent is what does the dissolving. Looping together two different units. This is both Unit 3 and Unit 4. Great job, everybody. All right, so go ahead on the whiteboard. Tell me, how are you feeling today about everything we just went over? That was a lot of review. Go ahead, tell me, how are you feeling about everything we went over? Again, this is basically all of Unit 3. We basically just reviewed all of Unit 3. The Unit 4 example will make sure to cover anything that comes from Unit 4 in tomorrow's lesson. All right, so make sure you're thinking through all of that. That will be on tomorrow's exam. Awesome. Looks like we're feeling kind of in the middle or better. That's where I want you to be. That's awesome. If you do feel like you're very confused or still need some help, make sure that when we take the exam tomorrow, if you want, you can always come to tutoring afterwards. I'll go ahead and I'll drop the tutoring link up on the board or up in the chat box. Let me find it really fast. All right, so here's the link to sign up for tutoring if you feel like you need help tomorrow after the exam. So only sign up for a link after tomorrow then. All right, looking good. So for today's attendance, I'm going to go ahead and send that to you in the chat box. You need to answer both parts. Sorry, one second. Let me get it. I forgot to put the links up. Hold on. 4K, October 6th. And let me grab that link really fast. Okay, here is the link in the chat box. Jalen, I haven't finished writing it yet, but I'm hoping it'll be about 10 questions. But they're not going to be like multiple choice, right? They're going to have different parts to them. So that's why you want to make sure you're in class. It's not just a multiple choice exam. You do have to do a little bit of work in each question, okay? All right, so there's your attendance discussion. So today, tell me in the chat box really quick, ionic bonds, what do they do with electrons? Do they share or transfer electrons? Tell me in the chat box. So what do ionic bonds do? I see Natalie typing. Again, the faster you participate, the faster I can dismiss you. Ionic bonds, do they share or transfer electrons? Awesome. I see Sylvia. I see Natalie working. I see Annette working, Ayla working. Yeah, amazing. Exactly. They're going to transfer electrons. Let me go ahead and bold this. So these will transfer electrons, whereas covalent bonds, what do covalent bonds do? What do covalent bonds do with their electrons? Think about like cooperate. So covalent bonds, what do they do with their electrons? Yes, Sylvia. Yes, Annette. I see people working in the chat box. Tell me, everybody, what do covalent bonds do? What do covalent bonds do? Thank you, Natalie. Thank you, Ryan. Yeah, they're going to share electrons. Make sure you answer both parts of these. So you should answer both that ionic bonds transfer electrons and covalent bonds share electrons. Please use complete sentences. Don't just write transfer share. That won't mean anything to me. That won't mean anything to you. All right, so ionic bonds transfer, covalent bonds share electrons. Thank you so much, everyone. Here's the link again if you need it. Click start a new thread and then go ahead and type this in. Make sure you include both parts, ionic bonds transfer, covalent bonds share. Thank you so much. I'll start logging people out in 1 minute. Have a great day, everybody.